Okay, so this is a lesson on volume of prisms and cylinders, and so I have this. So what I have right here is this prism, and this is the same one. This is the same one over here, but what I'd like you to notice is that I filled the bottom level completely with cubic units. So when we're finding volume, what we're really finding are the number of cubic units we can get on the inside. Those are cubic units, and that's what these green ones are. These are all cubic units that I've gotten here in a perfect arrangement. Notice it's in a 3 by 4 arrangement. 1, 2, 3 by 4. And that's the area of our base, and then I've filled it one layer high of cubic units. But the first thing we want to understand in figuring out volume is that we need to know the area of the base. In this particular case, the area of this base is 3 by 4, so that gets us the area of the base, which is 12 square units. And then what we do to find volume is we add layers. 1 layer, 2 layers, 3 layers, 4 layers, 5 layers. So we have 5 total layers, so that is our height in this instance. So we multiply that base area times the height. So volume is equal to the area of the base times the height. So in this particular example, I had a base area of 12, which I got by 3 times 4. I multiply by 5, and so I have a volume of 60 cubic units. And so my formula, as I said, this big B stands for area of the base. Now looking down below, I have a cylinder, 2 cylinders that are the same, and again I'm just trying to show you this layering idea let me get my pen just a little bit thicker. And once again, the volume for a cylinder will also be area of the base times the height, because once again I am just filling in the bottom or the base of the cylinder with cubic units. But notice they don't fit in an exact arrangement because they're cubic as opposed to fitting in a curved edged object. So pi helps us to make that happen. And then what I've done, and notice that the area of the base this time is going to be equal to pi r squared. So I would need to give you that. Let's say that that's 3 units in this particular example. So that's the same radius as down on the bottom level there. And so from there we can figure out the area of the base, which is equal to pi times 3 squared. And then what I'm doing is so that's going to, well, let's go ahead and figure that out. So that's going to equal 9 pi square units, and I'm going to multiply that by the number of layers high that I'm going, which you can see is 1 layer, 2 layers, 3 layers, 4 layers. So the height here is equal to 4. So my volume for this cylinder would equal 9 pi, which is my base area, times my height, which is 4. So the volume here would be 36 pi, which is a little bit more than 3 times 36 cubic units. That's what I would have here for my volume. So let's look at some examples here. So I've already done all the work here for you, but let's try to understand here. I've got a rectangular prism here that is 6 by 9 by 4, 6 feet by 9 feet by 4 feet. We're going to consider, it doesn't matter for a rectangular prism, but we'll consider the face that it sits on to be one of the bases. So we got to get the base area. So we're trying to get the area of the base, which this time is 6 feet by 9 feet, and that's kind of telling us that, we have, 1, 2, 3, 4, 5, 6, and we're going 9 deep here, right? And we're going to fill this with as many square units as we can get, so we'll end up with a base area of 54 square units on the base, and then we're going to start layering on top of that. We're going to go up 4 levels on that. I think I made too many there. So we're going to go up, 1 level. We're going to go up 4 levels to create all these cubic units inside of here. But this tells us how we can do it. Get area of the base, which is 54 times 4, and that accounts for the volume of 216 cubic feet. That's our volume for that rectangular prism. Now this next example is a triangular base prism, and notice that it has its bases it's not laying on its bases, it's laying on one of its lateral surface faces. We got to consider the triangles to be the bases here. So it's a right triangular base, so we can consider one of these legs of the right triangle. In this case, looks like I did 18. The other leg is the height of the base, and all this I'm figuring out the base area, which is 1/2 times 18 times 16, and then I'm going 22 layers high. That's my height. This would be my height if it was laying on the base, which we have to consider that to be the height for this type of prism, and that together gets us a volume of 3,168 cubic centimeters. So we have another, now what this example is about is if I give you a problem where I don't give you the height, but I give you the volume. So giving you the volume is 700 cubic centimeters. And what's the height? Well, we know the base area we can get by doing 5 times 14. So that's what this is right here. So I get the base area of 5 times 14, which is 70. So, and I don't know h. I'm given my volume of 700. So I'm just going to do, so I have this equation right here of 700 equals 70h. I don't really let you guys do that yet. These are some notes from a ITA class, so I'm going to take that step out of there and show you the way we do it. We like to use reciprocals, so I'm going to multiply both sides by 1/70th, and I'm going to get that the height is equal to 10 centimeters. In this next example, I have a cylinder where I don't know the height. That's what I don't know. I'm going to be given the volume here is 567 pi cubic meters, and again I don't know the height. So let me slide this up here and change one thing here. I'm not going to do it that way. So what I do is and let me just do this all together here, get rid of this all together, and so I can show you the steps on this a little better. So I have, if I'm given my volume is 567 pi cubic feet, and I set that equal to the base times the height. Well, the base is a circle, so it's pi r squared, and then times the height. Now remember, I know the radius. I was given the radius up here is 9. So I'm going to say 567 pi equals pi times 9 squared times h. I can cross off the pi's since it's both sides, and I got 567 equals 81h. I'm going to multiply both sides by, multiply by 1 over 81, and that does go evenly into 567, so you can see I got an answer there of h equals 7 meters. In this example here, I've got a combination volume to find, and this is actually easier than it was with surface area, since I'm not worried about the surface of these. It's just about summing the two volumes, summing the volume of the cylinder, summing the volume of this prism. Now, what you can see here is that the prism has a base of 11 times 9, so that's my base area right there, times the height, which is 2. So this 198 cubic inches is the volume of the prism. The cylinder has a it's a little hard to see there, but that has a diameter of 4, so its radius is 2. So that's where this 2 squared comes from. Pi times 2 squared is the area of the base of this, times the height, which is 7. That's given right there. And I got to keep these calculations separate because this has pi and this doesn't, so I leave my volume at 28 pi plus 198 cubic inches. All right. So I have this is a lesson on now we're moving on to 10.3, and that's going to be volume of pyramids and cones. I just happen to start here with cones. So what I'd like you to see is, notice I put a cylinder side by side by this cone, and I actually drew the cone. I'll do it again a little more. I drew the cone inside of the cylinder, and the reason I did that is because you're going to figure out the volume of a cone basically the same way as a cylinder. It's still going to be area of the base times the height, except a cone that has the same base area as a partner cylinder and the same height. Now we really are concerned about the height, no longer concerned about the slant height. That's the height of a cone. It's no longer the slant height. That the volume of a cone that has the same base area and same height as a cylinder that sits inside of, its volume will be 1/3 of that of the cylinder. So you use the same calculations, except it's 1/3 of that volume. The same is going to be true, and the same is going to be true down below here with a prism. So if I draw a pyramid. If I draw a pyramid inside that has the same height and base area, I'm going to kind of just redraw this over here. And that the volume of this pyramid right now will be, that I have right here, will be 1/3 of what this volume of this prism is over here, again assuming that the base areas are the same. Didn't quite succeed there, and that their heights are the same. That this pyramid will take up 1/3 of the volume of this pyramid. So that's how we understand the formula. It's just 1/3 of what it would be. The pyramid's volume is 1/3 of what it would be if it was a prism with the same base area and height. So let's look at some examples. So here I have a cone, and so remember your formula is volume equals 1/3 area of the base times the height. And we're going to be sticking with that all the way through here. Well, this part of it is the B right here. This is the B. And notice that my radius, which I just sort of covered up here, is 5 centimeters. So that's where, so to get the base area, we got to go pi times 5 squared. That gets us this base area. We're going to multiply by the height, just as we would do for a cylinder, but we multiply everything by 1/3. So I did 5 squared is 25. I multiply that by 7.6, and then I divide by 3 on my calculator, and I got 63.3 pi cubic meters. Now this next example, I'm going to use this same formula. Let me do the work on the side since I can't see it here. So this is this is a pyramid this time, so it's 1/3 area of the base times the height. Notice that what I've done here, and it's a square base pyramid, so I just want to do 6 squared since it's a square here, right? I gotta just multiply 6 times 6 and times the height, which is 9. And so I get 36 times 9, but I can take 36 and divide it by 3, which is 12. So 12 times 9, it gets this 108 cubic centimeters. I have a
You have what?
So I have this cone right here, and a little bit different on this one is that I'm given the diameter this time, so that means my radius is going to be 6.5. I'm going to square that. I'm going to multiply that by the height, which is 9 right here. Notice that over here I had times 1/3, but since 1/3 of 9 is 3, that's where I canceled out the 9 and the 1/3 and got this 3 right here. So it's going to be 6.5 squared times 3, and all that times pi gets 126.75 pi cubic inches. This next pyramid is just a little bit different. It's got a triangular base, so it's still going to be volume equals 1/3 area of the base times the height, but notice that since we have a base that's a triangle now, that's why it's 1/2 times 10 times the height of the base, which is 5. So that gets us a base area of 25. We multiply by the height of the pyramid of 14, and then we multiply all that by 1/3, and we get 116.6 repeating cubic inches. Last two examples here. I have a pyramid that's inside of a prism, and it wants to find the space inside that's not taken up by the pyramid. So what I am suggesting to you, to find one like this, since you know that the pyramid its volume is 1/3 of the volume of the prism that has the same height and the same base area, then the space that would be left over would be 2/3 of the volume of the prism. So I'm just going to find the volume of the prism and multiply by 2/3. That's what I've done here. The prism has a volume of, well, its base area is 8 times 8. Its height is 10, same as that. And so then I want to take 2/3 of all that. I just left it in fraction form. So it's 1,280 divided by 3 cubic feet. This pyramid over here has a hexagon as a base area. We haven't talked about the formula. We won't do that till geometry, but when you take geometry in 9th or 10th grade, but it gave you the base area here for this hexagon base, and that's 35 square meters, but you still just multiply by the height, that base area times the height, and multiply by 1/3, and all that came to 105 cubic meters. And that is the end of the lesson.